For this lesson, we're going to be looking at factoring completely. So we've learned several different ways to factor. We learned about difference of squares. We learned about 2 different ways to factor trinomials depending on whether a equals 1 or not, and also factoring by grouping and factoring out the GCF. Now we're going to put that all together, and so we'll have several examples where you're going to have to look at the problem and figure out what type of factoring you are going to need to do. And so I have this chart for you to kind of follow through the chart to see what type of factoring you're going to need to do for that problem. And so the first step always is to look for a GCF. A lot of times your problem can become a lot easier if you factor out that GCF in the very beginning. And so our first step is always just to check whether there's a GCF or not. Now, sometimes there won't be, sometimes there will, but after, if there's only 2 terms and you can still factor further, then you're going to be doing a difference of squares. And so if you take out your GCF, or maybe there's not a GCF, and you have something in the form of a squared minus b squared, then we're going to factor that using difference of squares. So for example, I have x squared minus 49. So looking at that, I see I don't have a GCF because 49 doesn't have an x with it. There's no number with x squared. But I do notice that they are a difference of squares. And so I can see x squared, that's the same thing as, put parentheses around that. And then 49 is the same thing as 7 squared. And again, you can always check that by just doing the square root of 49. If you put that in your calculator, you should get 7. And so we learned the pattern with difference of squares is that if we have 2 squares and we're subtracting them, then those always factor out in this form of one being a plus, the other being a minus, and then we just put our x and 7 in there. So I see when I factor out x squared minus 49, I have x plus 7, x minus 7. X and 7 are the same in both, but one has a plus and the other has a minus. Okay, let's say when you take out the GCF, or maybe there wasn't a GCF and you have 3 terms, there are 2 different ways that we're going to end up factoring that. The first one, if you have a trinomial and you have a is equal to 1, so there's not a number that you see out in front of x squared, then that's when we can use our shortcut. And those when we will find factors of c that add to b. So for example, I have x squared plus 12x plus 32. I see I don't have a number in front of x squared that I see, it's just a 1. And so that means I can go straight to looking for 2 numbers that multiply to 32, but then I want them to add to equal to 12. Well, 1 plus 32, no. 2 times 16 is 32, but that doesn't add to 12. 4 times 8 is 32, and I see that that does also add to 12. And so my answer here would be x plus 4 times x plus 8. I just put my 2 factors in the parentheses. So those ones are nice when we can use our shortcut, but you may also get one in the form of ax squared plus bx plus c. So this is when a does not equal to 1. And that is when we will use our AC method. So for instance, here I have 2x squared plus 11x plus 5. I'm going to start by doing a times c. So 2 times 5, I get 10. So over here. And so I'm looking for 2 numbers that multiply to 10 and then add to equal my b value, which is 11. So my factors of 10, I have 1 times 10, 2 times 5, and I see that 1 plus 10 gets me that 11. So I want to split the middle. Instead of 11x, I'm going to have 1x plus 10x. And then I'm going to bring down my first and last term. So I have 2x squared plus 1x, and then 10x plus 5. And now from here, since we have 4 terms, we can go ahead and factor by grouping. And so my GCF in my first pair is just x. My GCF in my second pair is 5. So when I factor out x, I'm left with x plus 1. When I factor out 5, I'm left with, oops, that should be a 2x. 2x plus 1. And then I bring my 2 GCFs into their own parentheses, and then I have 2x plus 1. And so we see the reason why we can't do our shortcut here is because of this 2 that needs to be with this x. Our shortcut only works when they're both going to be x in that first part. Now let's say you found a GCF, maybe you didn't, and now we have 4 terms. That is when we're going to be factoring by grouping. And when we factor by grouping, that's when we find the GCF of our 2 pairs. And so looking at my first pair here, my GCF among my numbers is 2. And then I see that they also share an x squared. In my second pairing, I see my GCF is 3. So taking out 2x squared from my first pair, 2x cubed divided by 2x squared, I'm left with x, minus 10 divided by 2 is 5, x squared divided by x squared is just 1. I put my GCF out in front, 3x divided by 3, I get x, negative 15 divided by 3, I get negative 5. I see I have the same thing here. That clues me in that I did it right, and so I can put my 2 GCFs together to get 2x squared plus 3, and then times x minus 5.